So, thank you all for attending my talk on accessing the Win32 API in PowerShell. Appreciate it. It's the end of the day, so if you do fall asleep, I certainly won't hold it against you. Firstly, thank you very much to our sponsors. That was very tasty Patch My PC lunch, and also Chocolatey, both great companies. So brief little bit about me. I'm principal consultant at Power on Platforms. I'm also the lead developer of a product called DPC, which has heavy interactions with the Win32 API, hence I know a little bit about it, and so trying to share that knowledge with you guys. So what is the Win32 API? Well, it's officially now known as the Windows API, but pretty much no one calls it that, apart from Microsoft. It is written in C, and it was originally released in 1993 for Windows NT. So it's older than some of the people in this room. But it's actually based on the Win16 API, and they followed a lot of the same conventions and maintained a reasonable level of backwards compatibility from Windows 1.0 all the way back in 1985. So we're talking about some of the oldest tech that Microsoft still kind of deals with and actively supports. So what is a Windows API? What's it actually doing? Well, it's the core set of interfaces for interacting with Windows, which means that pretty much anything and everything that you're doing, from PowerShell to HTML to C#, everything ends up back. If you're interacting with the Windows operating system, whether it's creating a window or modifying the file system, you end up back at the Win32 API at some point at some time. And everything else is just abstractions and makes it easier kind of on top of that. So we're bypassing a whole bunch of frameworks and abstractions to make things easier when we're accessing the Win32 API directly. So that kind of causes issues, right? Well, it certainly creates challenges. So the first big one is memory management. C and C-like languages assume that the programmer or developer knows what they're doing with memory and is directly managing that memory on behalf of the program and on behalf of the operating system. With PowerShell, with C#, things like that, a lot of that is kind of abstracted away because, quite frankly, the operating system can generally do it better than us in most cases, although there are, of course, some performance impacts. The syntax has a tendency to be rather archaic and unintuitive, again, kind of dating back all the way to the mid-80s in some cases. It is certainly not as verbose and easy to understand as things like PowerShell. And the documentation is questionable or limited in some cases. And we'll kind of dig into some of that. And part of this talk is actually about how you can get around some of those limitations in the documentation and how you can look or find things out that isn't where you expect it to be. So the end goal here is just to kind of give you guys an example of how to do this stuff. We're going to be interacting with a Win32 API called enum ras entries. And what this will do is it will look for all of the VPN profiles that you've got currently deployed onto your system and return back the name of the profile, whether it's a system or a user profile, and the location of where it's saved on the operating system. Ultimately, the concepts that I'm talking about here are pretty much universal to any Win32 API. This just happens to be one of the ones that I'm most familiar with, and it shows off some of the challenges that you have to deal with when kind of digging into these areas in depth. So, Invoke is your friend. This is a system that Microsoft wrote that's built into the .NET framework for allowing us to take a nice high-level managed language like PowerShell, C# and access the scary wide world of unmanaged C. So what we're going to be doing to access that API is we're going to need to define some constants to access things. We need to define some data structures. We then need to define the pinvoke interface. So this is telling pinvoke where to find my Win32 API and what that actually looks like so that it can try and match that up, both from a managed and an unmanaged perspective. And then finally, we can access the interface. And just as a bit of a visual representation of what the code or what pinvoke is doing for us behind the scenes is that we've got kind of PowerShell, which we're going to be writing some C# code in, and I'll kind of show you that in a minute. So that's going to dynamically compile the C# code, which is then going to make a managed system call to pinvoke. Pinvoke does a whole bunch of magic, which kind of lines the whole managed and unmanaged things up, does a lot of the string manipulation, so you don't have to worry about pointers and null terminated strings, all of that stuff. That kind of happens in the background. And then that will make the actual Windows API calls on our behalf. And then the Windows APIs, they will go using private API calls that Microsoft don't talk about and do stuff within Windows depending on what your API is and what you're trying to do. So there is a reasonable level of official documentation. Probably can't see it too well on here, but the links for this, well, the presentation will be made available online. But ultimately, there is a full API index on the Microsoft website. There is also a website called pinvoke.net, and this is a really good starting point because it's a community contributed, almost like a wiki, which defines a lot of the interfaces from, it's designed for C#, but ultimately, when we're accessing it from PowerShell, we're generally using a C#-like interface anyway, so you can translate relatively easily between them. So specifically, we're looking at the RAS enums entry part of the documentation. And also another link that is useful is the description of the underlying data types that are used as part of the Win32 API, because some of them will need to be translated, and we'll kind of see what that looks like in a second. So looking at the documentation, you'll notice that I've talked about RAS enum entries, but there is an A on the end, and there's also a W version of that. And that is a designation for ANSI or Unicode-based encoding of your strings. Generally, when you're actually accessing them, the A and the W bits get handled behind the scenes by pinvoke and actually Windows itself. There's a virtual function that is automatically used to convert it one way or the other, and I'll show you how to set that in a second. But you can effectively just ignore the A and the W from a documentation perspective. In 99% of the cases, I certainly don't know the entire API. Generally, you should be using Unicode rather than ANSI nowadays anyway. So if in doubt, look at the W version of the documentation. But you'll see here we have a bunch of inputs and outputs. You've got a bunch of what look really rather weird, but they're actually the defined data types, and the oh so useful unnamed parameters. So because C-type languages are you're managing your own memory, it's very common to pass data structures by reference rather than by value. And you generally will need to return back more values than the single return code. So in a more like a typical PowerShell, you'll have a function and you'll return back a data object with a bunch of data on it. In the C convention, you will generally return back an error code, with 0 being I succeeded and anything else being I broke in various ways. So in that case, it's like, well, how do you get the actual data or the output back out of that function? And that's where you are passing by reference, i.e. by memory pointer, and you're actually sending those references into the function to then get an updated reference back out to the data that you actually care about. From a data structure perspective, we've got these STRs. They are strings of varying types. Again, that type documentation will give you all the details on exactly what that looks like. We have a value called RAS entry name, and that is a data type that we're going to have a look at in a second. And we've got these LPD words, so they are equivalent to integers or enums. So luckily, they provide a bit more information as to what those parameters should be, even though they don't give them nice names. So the first one's nice and easy, must be null. That's simple enough. The second one, if you take the time to actually read that, basically what it's looking for is a string pointing at the rasphone.pbk file that is storing the VPN entries. So again, string, that's nice and easy. Next, we need an array of RAS entry name objects, and you'll see there's a nice hyperlink there to take us to that, and we'll have a look at that in a second. But effectively, this is the core of the return value, which actually provides that input that I was showing on the screen earlier. Then the next one is we need to send it the amount of memory that is taken up by that RAS entry object, because the function, the API needs to, well, validate that we're not doing weird things with memory, and also it needs to understand how many data objects it's got, because it has to actually place the correct data in the correct parts of memory, so that we can return back, or we can read the data back out effectively. And then the final entry is it's going to return back the number of entries of the RAS entry name that we've got. So we can send it an array of 10 items, and it will say, oh, I've only filled in the first 5. Because again, memory management. The final thing on this page that's very useful to know is which DLL it's actually stored in. It's generally the name of the API, something 32.dll. You can normally kind of find it and Google it if it's not on the bottom of the page, but you'll need that when you're calling the pinvoke to tell it where to look to find this actual function. And yes, we can see pretty much everything is of kind of that era. Yeah? I cannot provide you a license for Windows 2000. I don't think I've ever actually dealt with it, but yes. Yeah, making Rob feel old at the back there. You can still get it on MSDM, but yeah. So this is the data structure for RAS entry, and you can think of this, if you've not dealt with structures before, kind of a bit like a class or a data object. From a PowerShell perspective. There's a couple of nuances here. The first one being that we've got this weird hash if win_var. Now, unlike in PowerShell, the hash in C-like languages is a preprocessor command, which means it runs before it then tries to compile it. So what it's effectively saying is that before 0x500, and we'll get into that in a second, the only things in that data structure is DW size and SZ entry name. If it's a greater version than X500, then it also includes this DW flag and the phone book path entries. So one of the things that this absolutely doesn't tell us is what that value should be. So what I'll show you is how you can find that stuff out in a second. But it then does go on to talk through what each of these values are. For example, the DW flags is a nice enum of either ren all users or ren user, but again, doesn't actually helpfully tell us what those values are. Are they 0? Are they 1? Is it 99? Etc. So, Windows SDK to the rescue. Ultimately, the the header files that we're using are actually part of the underlying operating system source code. So when Microsoft compiles a new version of Windows, they also create a new version of the SDK, which includes all of the header files that allow us to interact with the operating system. Now, and you can go off and download that either for the main release builds or even for when they do the insiders and the debug versions and all of that, they will ship specific versions of the SDK for those as well. This is the path on my local system to the Win11 RTM version. You'll see the 22000. It all comes up under the kind of 10 dots. The 22H2 version has a slightly different build number, etc. The modern versions of Windows, they change some things, so it's always probably worth checking, or more to the point, being aware of the versions of the code that you're going to be running this on. But generally, it's, at least in the ras.h approach, they've not updated things in years, so you're generally safe just looking at the, one that is vaguely recent. But yeah, you always generally want to check. So within there's a bunch of folders within that location. Is the most useful. It's the user mode sets, i.e. you're not doing kernel drivers, you're not doing kernel stuff. We're in kind of main application mode, and so most of the stuff that we're going to be doing with is in user mode. There is some stuff in shared, so some of the more underlying data types, things like winerror.h, which defines all of the Windows error codes in excruciating detail. It's about 60,000 of them or something. That's in shared rather than in user mode because that's also used by kind of the Microsoft kernel stuff. And then there's a couple of other things relating to the kind of universal runtimes, WinRT, etc. No one really deals with that stuff, so you generally don't want to be worrying about it. If you're going down the Win32 route, you're generally wanting the proper Win32 APIs anyway. So I've just taken the liberty of just grabbing the bits out of the relevant API locations. So at the top of ras.h, for example, it's got this nice detail of all the different versions and what they actually mean from an underlying code perspective. So you'll see there that there's actually a nice little Windows Blue thing that was never officially confirmed, but yes, it is in the source code. It turned into 8.1, yeah. But there was some rumours of it going in a completely different direction, hence the different code name and things. But yeah, it's effectively 8.1. So when we go back, it's 0x500. That is Windows 2000. So we can safely assume that anything that we're going to be running our code on is going to use the full set of the data set rather than just the first two. We can also find the definition of those enum values. So ren user is 0, ren all users is 1. And if you don't know which file these are in, this is where VS Code comes in really handy. If you just open in VS Code the whole of and you do the whole multi-file search thing for one of these values, it will take you straight to the location. Happy days. Saves an awful lot of time. And then we also needed, I forgot to mention it earlier, but we needed to, what you see here is that the entry name is of type ras max entry name +1. So it's of a, in C, you don't have dynamic strings as such, you will generally have fixed length strings. And again, because we have to manage our own memory, we need to know what that is so that we can match that in the PowerShell world to get to the C world correctly. So we just needed to find out that max entry name is 256, so that value will be 257. Max device is 128, and max callback number is the same as phone number, but we don't care about that. So now that we've got all of that information, we can actually start to build the script that allows us to access this stuff. So There's multiple ways that you can bring this code in, and I'll talk about that in a minute. I'm just going to run through the single block approach because it's the easiest to kind of talk through, and we'll talk through how some of the other options work depending on time. So what I'm doing here is I'm creating a static C# class which defines the max entry names and the max paths. You don't necessarily need to do this. This is mainly because I copied some code out of C# and cut it down a bit, so it just kind of matches my existing naming conventions more than anything. We then define the profile enum to be ren all users, and being 0 and 1. You don't necessarily need to do this again. You could just make it an integer. I put it into this talk more to show you what's possible and how to interact with that stuff. But if you're going for a quick and dirty and you don't really care about that value, make it an int, save yourself some time and effort. So now we get on to the more interesting stuff, and you'll see at the top here we've got this struct layout with a char set. So this is telling Pinvoke how to deal with some of the magical stuff that it does behind the scenes. So we're telling it that these values must be in this order in memory, because otherwise, in a managed language, I really don't care whether actually from a memory perspective the entry name is before or after the location. It makes no difference to me as long as I can get access to that value. When we're dealing with unmanaged memory, because Windows is going to start writing data in a specific order, we need to be able to pull it out in that specific order as well. So we're just telling Pinvoke, don't mess with what I've told you. And then the whole char set Unicode is saying use the W version of the function, not the A version. It generally shouldn't matter whether you're using one or the other, but whatever you do, make sure you're using the same across all of your APIs in the same script. You will break things if you have one set to ANSI, one set to Unicode. So then we are using this Marshall as, because again, in PowerShell, in C#, a string is of variable type, so we're saying we are going to fix this to that specific type, and therefore you're going to allocate the memory properly. And we're just telling it to be of a T string, which is kind of the type of string that it told us about beforehand. And then because a enum is just an integer behind the scenes, from a data perspective, they are actually identical. So we can just substitute, rather than having an integer, we can just say it's of this enum type and it will do that mapping automatically, which is really nice. And then we've got another string there. So then we define the actual interface that we're going to use. So again, we've got a char set. We're setting it to throw an error if it can't map strings correctly. And then we are defining so that first one, even though it said in the original documentation it needed to be a string, it also then said that we need to send it null. And PowerShell's null is not the same as a C null. So the easiest way to send a C type null is to make it an int pointer and just send it an int pointer 0, which is kind of a hard-coded way of just going, this is null, ignore it. So what you'll see there is that you don't have to marry the documentation to the implementation 100% if there are specific reasons not to. There's also a lot of reasons why it will break it, but that's the joys of the Win32 API and the trial and error. Now, we've had to put an int pointer in for the RAS memory, or for the RAS entry names as well. The reason for that you don't need to do this if you're using C#. This is one of the joys of putting yet another layer on top of that, which is PowerShell, where because of the way that PowerShell interacts with data object types, and specifically arrays of data object types, it turns out if you create an array of C# objects, it becomes read-only, or something akin to read-only, that I couldn't figure out when I was building this out. So you have to go down the route of direct memory management yourself, which has its own joys, but I'll talk through all of that. And then, yeah, you've just got defining the ins and outs, etc. So then the next bit is the add type. So this is effectively compile my code and add it to the Windows environment. We are then, we've got a variable at the top that just says we need to do an initial entry of at least 1, and that's just a quick check to say you've got to have at least 1. A lot of the documentation will say you can send null to these things. Again, because of the way that you're layering PowerShell over the top, the memory management gets a bit upset, so you generally want to have at least 1 object there, and it will kind of accept that. So then what we're doing on this line is we are getting the data size of the RAS entry name object, and we're going to use that in a few places, and we're saying that the current entity count is 0. So we've got to pre-initialize our variables, which again is a bit weird from a PowerShell context. But again, if we don't pre-initialize it, then the garbage collector won't define a memory location for it, and then you'll get access denied errors, etc. So what we're then doing is the RAS entry name object has a struct size element in it, and that is again used by the RAS entry object to understand its own internal memory management side. Not all APIs do that, but a significant number of them will have something that along the lines of DW size that you'll need to set to the actual data object size. So effectively it knows which version it's dealing with. And then we allocate a giant block of memory. We are directly calling the underlying .NET kind of core CLI system to say, give me a block of memory that is the number of entries times the size of the entries. And then we're actually going to initialize that by copying a blank version of that structure with the DW size set into each of those locations within the memory block. And then finally, we get to call RAS enum entries. So we're setting it to 0, which is equivalent to null. We're giving it the string to the location. We are sending it the pointer to the beginning of the data block that we've just allocated. We're then saying this is the size of the data block. And we're sending it 0 because we are expecting back a reference to the number of entities that are in that file that it should be returning. And now there are effectively 3 results that can come out of this. There is something went really, really wrong, and you've got any number of different error codes that you can go and look up and find out what went wrong and why. You have 0, which is I succeeded and the memory has been successfully written. And you have 603, which is an interesting one, which is I didn't have enough space to fulfill the request. So if, for example, at the start we allocated a single line item, a single entry, but there's actually 2 VPN profiles on the system, it wants to write 2 of those RAS entries. So it's saying, I need more memory, please, and it will fill in the entity number so that we know that there are actually 2. Which means that we can actually go through that entire process again, but this time with the size of the block of memory that Windows is telling us we need. And this may seem a really weird way of doing this, but this is actually the convention in a lot of these kinds of programs and these kinds of languages. Did I mention that it's old? So effectively, we're just reallocating that big block of memory. We are, again, assigning that DW size or that struct size into each of the locations because otherwise it gets very upset. And then we get to call it again. And it's the exact same command, but this time with a larger block of memory. And this time, if it doesn't succeed, then we're just going to go, something went wrong. But finally, we don't actually want a giant block of random memory. We're in PowerShell. We want to have objects. We want to be able to use these things nicely. So we're using this pointer to structure method, and effectively we are jumping through the block of memory, and we're saying that first block, we know the size of it, that is of type that structure, so make it that structure, that class, that object. Move on to the next one, repeat, and we're just creating an array of those objects effectively. And if it succeeded the first time, we don't need to reallocate all the memory. We can just go straight to the assignment of the memory. Again, not the cleanest script. There's a whole bunch of repetition in here, but it's more that it gives a clarity of what it's doing rather than a particular, like, dry principles. So eventually, right at the end, we're just looping through those entities, and we can kind of show that it is being used. So loading that dependent code. So what I showed you was the one big C# block approach, which is the easiest to kind of deal with. But if you are starting to use lots of different APIs and things, then that can become quite an unwieldy block of text in the middle of your PowerShell code. You can just hard code those values, so things like those constants, they didn't need to be variables that are referenced. You can just make them numbers. You could, even because it is just a block of text that then gets compiled, you can use your your PowerShell to start dynamically updating your code with kind of PowerShell conventions. And finally, what you can do is you can output the assemblies. So as part of the add type, there's an option of output assembly, which will store that to a DLL. And then if you need to use that in another part of your or in a different type, you can then reference that DLL. And so the reason for that is that when you're doing the add type, it's kind of compiling it outside of the environment or the process. So when you're compiling that RAS entry name object, we're actually referencing the RAS constants object, and we need that profile type object. So if we had put that in its own block, then it doesn't know about those other pieces of compiled code. So that's why we have to reference them in with DLLs. But there's examples of all of that on my GitHub, which you can see all the different options and the ways you can do things. So a couple of gotchas. Once you've added a type into the PowerShell environment, there's no real way to remove it. So if you are changing the data types, things like that, you're moving from a specific type to a pointer or from an enum to an int, that kind of thing, you will get errors when you try and add it again. And the only real way to handle that is to flush the entire environment, generally close the program, reopen it, etc. So you'll probably be doing a lot of restarting of your IDE as you're getting those initial data types created. Once they've solidified and you've got them working and you're just doing the rest of the PowerShell bit, it becomes more normal development. As I previously mentioned, null is not the same as a C# or a C null. Int pointer 0 is much more consistent in that approach. I've put a little kind of demonstrator program of that in the GitHub repo as well, called null is fun or something, because I had a couple of beverages at that point. And as previously mentioned, the arrays of C# objects do not perform how you'd expect. You can write to them, it will accept the write, but it's not saved anywhere. And when you try and reference back to it, it's just the original default. And again, if you create an object, you modify it, you put it into an array, then you try and it will take those values, but when you try and make any modifications again into that array, it just goes back to it doesn't seem to save them or store them in memory for some reason. And finally, Windows really doesn't like writing to memory outside of its known processes. There's a type of app that does that called malware. So Windows, many years ago, put some pretty hard constraints in where it tracks what memory is known about by a particular process. And if you try to write outside of that, it just kills the entire process. And it just goes, nope. And so if you find when you're trying to run some of your code, it just starts restarting your PowerShell or your ISE or your VS Code, you're probably writing to memory that you shouldn't be. And Windows is going, I'm not letting you do that. You're trying to corrupt my kernel. So finally, I know this is a PowerShell day, and I've just been talking about doing this with PowerShell, but have you considered C#? When you're dealing with the Win32 APIs, you are dealing with a completely different approach to pretty much everything. And there are times when PowerShell scripts are the right approach, but it's one of these times where you should definitely be stopping and thinking and going, is this the right approach for this application or this type? There are multiple ways you could do it. You could create a C# PowerShell module, which is much more integrated with the C# approach. You could create an application that does the specific API access that you're trying to do, and then just calling that from PowerShell. Or you could ultimately just rewrite what you're trying to do as an application, whether that is C# or otherwise. Yeah, so?
I feel obliged to point out that PowerShell can actually be instrumented to also natively supporting the DLL import attributes with like 50 lines of code, because all the building blocks, like passing the attributes and binding like to .NET and so on, is already in PowerShell. It's just a question of like the wiring not being there.
All right.
I'll send you a link after.
Yeah, that'd be useful. Interesting. But there are a couple of modules that what I've shown you was a particularly raw way of doing it. You've got PS Reflect, which is a nice way of kind of PowerShellarizing the C# code, so it's less C# and more kind of custom PowerShell objects. And then there's a great set of functions that for certain APIs, someone's already done the hard work of mapping the Win32 API to the PS Reflect approach. And then Lee Holmes has a great Invoke Win32 script, which has a great way of accessing some of the APIs as well. When I tried to use both of these, I got the enum entry working on PS Reflect eventually. I couldn't get it working on Lee Holmes' approach because of the way that the RAS enum entries requires you to do that direct memory management yourself. I'm sure there are ways of doing it, but I took the path of the least resistance when I got it working, to be honest. So that's kind of a whistle-stop tour of everything. I'm going to put the code up on my GitHub. There's a presentations repo in there that has all my past presentations in it. This will be added to that eventually, and by eventually I probably mean the weekend. You can reach me on Twitter at LeoDarcy1. More than happy to help or answer questions on this stuff. I'm certainly not the world's greatest expert on it, but I've done a bit of it. So yeah, any questions? I will be drinking beer. I will be buying my own beer. For you, I might buy you a beer, but I'm not buying beer for everyone in the conference.
Damn it, we almost had it.
All right then. Well, if there's no questions, thank you very much.